Intensive practice 7.3, questions number 1. ABCD is a parallelogram which diagonals intersect at E. Given A, negative 5, 3, B, 0, negative 2, and C, 3, 5, finds A, the coordinates of D and E. So let's say this is the positions of the point A, B, C based on the coordinates given. Then point D probably will be somewhere here. And when we connect all the points together, then we're going to form the parallelogram ABCD. Then the intersection point E will be here. So remember, the diagonals in the parallelogram bisect each other, which means the points E here will be the midpoint for AC and also for BD. Then the ratio in the diagonal will be 1 to 1. So first we're going to find the coordinate E. So refer to the coordinate A and C. The x coordinates of point E will be negative 5 plus 3, then divide by the total ratio, which is 2. And for the y coordinate, it will be 3 plus 5, then divide by the total ratio, 2. So here we're going to get negative 2 divided by 2 and 8 divided by 2. So the coordinate E will be negative 1, 4. So now we can find the coordinates for the point D. So here when we sum up the x coordinate for the point D and B, which is x plus 0, and divide it with the total ratio, which is 2, this will give us the x coordinate of the point E, which is negative 1. So here x is equal to negative 1 times 2, which is negative 2. And when we sum up the y coordinate for the D and B, which is y plus negative 2, and divide by the total ratio 2, this will give us the y coordinate of the point E, which is 4. So here we're going to get y minus 2 equal to 4 times 2, which is 8. So y is equal to 8 plus 2, which is equal to 10. So the coordinate D will be negative 2, 10. Questions B. Finds the area of parallelogram ABCD. As we already know the coordinates for the point ABCD, then we can find this area using the shoelace formula. So here we're going to arrange the coordinate anti-clockwise. So this will be 1 over 2. So here let's say I start with the coordinate C. So 3, 5 followed by negative 2, 10, negative 5, 3, 0, negative 2, and end with the coordinate C again. So here we're going to sum up all products in this direction. So bracket 3 times 10, we're going to get 30, negative 2 times 3, negative 6, negative 5 times negative 2, we're going to get positive 10, and 0 times 5, we're going to get 0. Then minus the sum of all products in these directions. So bracket 5 times negative 2, we're going to get negative 10. 10 times negative 5, negative 50. 3 times 0, 0. And negative 2 times 3, we're going to get negative 6. So this is equal to 1 over 2. So the first bracket will give us the answer of 34. And minus the total in the second bracket, which will be negative 66. So this is the same as 34 plus 66. So 1 over 2 times 100. So the area will equal to 50 units square. Questions number 2. PQRS is a rhombus with coordinates P, 3, 3, Q, H3, R, negative 5, negative 1, and S, 0, K. Finds A, the value of H and K. So this will be the positions of the point P and R based on the coordinates. So when the rhombus PQRS arranged clockwise, then this will be the point Q and this will be the point S. But if the rhombus PQRS arranged anti-clockwise, then here will be the positions of the point Q and here will be the position of point S. So no matter in what orientations, the point Q and S will be the opposite points, and the point P and R will be the other opposite points. So for a rhombus, the length of each sides are equal, and the diagonals of the rhombus is perpendicular bisector to each other. So the intersection point between the diagonal will also be the midpoint. So first I'm going to find the midpoint of PR. It will be -5 plus 3, then divide by the total ratio, which is 2, and -1 plus 3 divided by 2. So this is equal to -2 divided by 2 and 2 divided by 2. So the coordinate of the midpoint will be -1, 1. So the coordinate -1, 1 will also be the midpoint for the QS. So when we sum up the x coordinates of the points Q and S and divide it by 2, this will give us the answer of the -1. H plus 0 divided by 2 is equal to -1. So H is equal to -1 times 2, which is equal to -2. And when we sum up the y coordinate of point Q and S and divide it by 2, it will give us the coordinate of 1. So here 3 plus k divided by 2, this is equal to 1. So 3 plus k is equal to 2. So k is equal to 2 minus 3, which is equal to -1. So this will be the rhombus PQRS look like. Questions B. Finds the area of rhombus PQRS. As we know the coordinates of each point, so here we can solve this using the shoelace formula. So here I'm going to arrange the coordinate anti-clockwise. Start with the coordinate P. So 1 over 2 times 3, 3. So the second coordinate will be -2, 3, followed by -5, -1, 0, -1, and end with the first coordinates again. So this is equal to 1 over 2 times the sum of all products in these directions. So bracket 3 times 3, we're going to get +9, -2 times -1, +2, -5 times -1, +5, and 0 times 3, this will be 0. Then minus the sum of all products in these directions. So bracket 3 times -2 is -6, 3 times -5, -15, -1 times 0, this is 0, and -1 times 3, this one will be -3. So 1 over 2, so the answer in the first bracket is equal to 16, then minus the sum in the second bracket is -24. So this is the same as 16 plus 24. So 1 over 2 times 40. So the answer will be 20 units square. Questions number 3. Given 3 points A, -1, -5, B, 2, 1, and C, 6, 9. A finds the area of the triangle ABC. So as we know the coordinate for each point, then we can find the area using the shoelace formula. So here I'm going to arrange the coordinate just using the points ABC. So I'm going to start with A, -1, -5, followed by B, 2, 1, and C, 6, 9, and end with the coordinates A. Then I'm going to sum up of all products in this direction. So bracket, -1 times 1 is -1, 2 times 9, this one is +18, 6 times -5, this will be -30. Then minus the sum of all products in these directions. So bracket, -5 times 2, this will be -10, 1 times 6, +6, and 9 times -1 will be -9. So this is equal to 1 over 2 times. The sum in the first bracket will be -13, then minus the sum in the second bracket will be -13 as well. So this is equal to 1 over 2, -13 plus 13. So 1 over 2 times 0. So the answer for the area here is 0 unit square. Questions B. Based on the answer in A, what can you say about points A, B, and C? As the area of the triangle ABC is equal to 0, then we can set the points A, B, and C are collinear. Question number 4. Finds the area of a polygon with vertices 5, 2, -1, -3, 2, 6, 3, -2, -4, 0, and -3, 2. Here we're going to find the area using the shoelace formula. So we need to make sure the coordinates are arranged clockwise or anti-clockwise. So I'm going to plot all the coordinates here onto the Cartesian plane. So here I'm going to arrange the coordinate anti-clockwise. Start with the coordinates 2, 6. Then followed by -3, 2, -4, 0, -1, -3, 3, -2, 5, 2, and end with 2, 6. Then we're going to sum of all products in these directions. So 2 times 2, we're going to get positive 4. -3 times 0, this will be 0. -4 times -3, positive 12. -1 times -2, positive 2. 3 times 2, positive 6. And 5 times 6, this one will be positive 30. Then minus the sum of all products in these directions. So bracket 6 times -3 will be -18. 2 times -4, -8. 0 times -1, 0. -3 times 3, -9. -2 times 5, -10. And 2 times 2, positive 4. So here the total answer in the first bracket will be 54. Then minus the total answer in the second bracket will be -41. So this is the same as 54 plus 41. So this will be 1/2 times 95. So the answer will be 47.5 units square. Question number 5. Points A, 5, -1, B, 3, 3, and C, -6P are the vertices of a triangle. Finds the value of P if the area of the triangle ABC is 16 units square. So here we're going to use the shoelace formula to get the area. So this will be 1/2. So I'm just going to follow the coordinate ABC. So start with 5, -1, followed by 3, 3, -6P, then end with 5, -1. So the answer of this area is equal to 16. So next, I'm going to move this 1/2 to the right hand side. So on the left hand side, it will be the sum of all products in these directions. So bracket 5 times 3 will be positive 15. 3 times P, this one will be positive 3P. -6 times -1, positive 6. Then minus the sum of all products in these directions. So bracket -1 times 3 is -3. 3 times -6, so this will be -18. And P times 5, this will be positive 5P. So this is equal to 16 times 2, which is equal to 32. So here for the first bracket, we're going to get 21 plus 3P. And for the second bracket, we'll get -21 plus 5P. So this is equal to 32. So next, I'm going to get everything out of the bracket. So 21 plus 3P. So here will be positive 21. And this will be minus 5P. So this is equal to 32. So here 21 plus 21 will get 42. And positive 3P minus 5P is negative 2P. So next, I'm going to remove the modular signs. So here we have two possible answers. One is the positive 32, another one will be the negative 32. So first one is 42 minus 2P equal to the positive 32. And the other one will be 42 minus 2P. This is equal to negative 32. So here I'm going to move the negative 2p on the right hand side and 32 to the left hand side. So here I'm going to get positive 2p equal to 42 minus 32. So 2p is equal to 10. Then p is equal to 10 divided by 2, which is 5. And for the second one, I'm going to use the same method. So I'm going to get positive 2p equal to 42 plus 32. So 2p equal to 74. So p is equal to 74 divided by 2, which is equal to 37. Question number 6. Given 3 points P, 2, 2r minus 1, Q, r minus 1, r plus 1, and r plus 3, 0. If points P, Q, and R are on the same straight lines, find the possible value of R. So here you can find the R using the Shoeless formula, and the area that you find using the point PQR will equal to 0 because they are on the same straight lines. Or you can find the R using the gradient because on the same straight lines the gradients are equal. So here I'm going to find the R using the gradient. So first using the point P and Q. So here R plus 1 minus 2R minus 1 over R minus 1 minus 2. This is the same as the gradient when I using the point Q and R. So here R plus 1 minus 0 over R minus 1 minus R plus 3. So next we're going to get R plus 1. So here expand this, you're going to get negative 2R plus 1 over R minus 3. This is equal to R plus 1 over R minus 1 minus R minus 3. So next, 1 plus 1 will get positive 2 and R minus 2R will get negative R. As for the right hand side, we're going to get R plus 1 over, so the R minus R here will be cancel. So negative 1 minus 3 will get negative 4. To solve this, I'm going to use the cross multiplications method. So here, R minus 3 times R plus 1, this is the same as negative 4 times 2 minus R. So expand this, you will get R squared plus R minus 3R minus 3. This is the same, equal to negative 8 plus 4R. So this will be a quadratic equation. So to solve this, we're going to write the quadratic equations in general form. So next, I'm going to move everything to the left hand side. So R squared plus, so the R minus 3R here will be negative 2R. And when we move the positive 4R to the left hand side, it will be minus 4R and negative 3 plus 8. This is equal to 0. So next, R squared. So negative 2R minus 4R will be negative 6R. And negative 3 plus 8 will be positive 5. So next, we're going to factorize this. So this will be R minus 1. The other bracket will be R minus 5. So R is equal to 1 and the other R will be equal to 5. Question number 7. 3 points have coordinates A, 8A, B, negative 1, 2, and C, 3, 10. Finds the value of A if A, B, C are collinear. So this is more or less the same as the question 6. You can solve the A using the Shoeless formula. And the area will equal to 0 because the point A, B, C are collinear. Or you can solve this using the gradient. So again, here I'm going to show you using the gradient. So first, we're going to use the point A and B. So here, A minus 2 over 8 minus negative 1. This is the same as the gradient when we are using the point B and C. So here, 10 minus 2 over 3 minus negative 1. So next, A minus 2 over 8 plus 1 is equal to 9. So here, 10 minus 2 is 8 and 3 plus 1 is equal to 4. So here a minus 2 over 9, this is equal to 2. So a minus 2, this is equal to 2 times 9, which is equal to 18. Then a is equal to 18 plus 2, which is equal to 20. Questions B. Finds the value of a if the area of the triangle ABC is equal to 12 units square. So here we're going to solve this using the shoelace formula. So 1 over 2. So here I just going to follow the ABC. So add a, then followed by negative 1, 2, 3, 10, and end with add a. This is equal to 12. So next, I'm going to move the 1 over 2 to the right hand side. Then I'm going to sum of all products in these directions. So 8 times 2, here I'm going to get positive 16. Negative 1 times 10, negative 10. 3 times a, positive 3a. Then I'm going to minus the sum of all products in this direction. So bracket a times negative 1, this will be negative a. 2 times 3, positive 6. And 10 times 8, it will be positive 80. So this is equal to 12 times 2, which is 24. So here, the first bracket, we're going to get 6 plus 3a. And the second bracket will get negative a plus 86. So next, we're going to get everything out of the bracket. So we're going to get plus a and minus 86. So 3a plus a, here we'll get 4a, and 6 minus 86 is negative 80. So this is equal to 24. So next, we're going to remove the modulus signs. So here we have two answers. One is positive 24 and the other one will be the negative 24. So here 4a minus 80 equal to positive 24, or 4a minus 80 equal to negative 24. So for the first one, 4a is equal to 24 plus 80, which is equal to 104. Then a is equal to 104 divided by 4, which is equal to 26. And for the second one, 4a is equal to negative 24 plus 80, which is equal to 56. Then a is equal to 56 divided by 4, which is equal to 14. Question number 8. The diagram on the right shows an isosceles triangle EFG with vertices E, 0K, F, 4, 4, and G, 7, 8. EF and FG have the same length. A finds the value of K. So here we're going to use the information EF and FG have the same length to find the value of K. To find the length, we're going to refer to this formula. The distance EF will be square root of 0 minus 4 square plus K minus 4 square. And the distance FG will be the square root of 7 minus 4 square plus 8 minus 4 square. So next, I'm going to square both sides to cancel the square root. So now what left on the left hand side will be negative 4 square plus K minus 4 square. This is equal to 3 square plus 4 square. So negative 4 square, we're going to get positive 16, and expand the K minus 4, we're going to get K square minus 8 square plus 16. And on the right hand side, 3 square plus 4 square, we're going to get total of 25. So this is a quadratic equation, and to solve this, we're going to write this in general form. So I'm going to move the 25 to the left hand side and arrange this. So K square minus 8K. So 16 plus 16 will get 32, and minus the 25 is going to be positive 7. This is equal to 0. Next, factorize this. We're going to get K minus 1 and K minus 7 equal to 0. Then the value of K will be K equal to 1, and the other value of K is equal to 7. So here, based on the diagram, the value of k is in between 8 and 4. Therefore, we're going to reject the answer k equal to 1. And the correct value for k will be k equal to 7. Questions B. H is a point on the lines y equal to 11 such that EH equal to GH. Finds number 1 the coordinate of H. So y equal to 11 is a horizontal straight lines look like this. So let's say here is the point H. So the distance EH is equal to GH. For this point H, we didn't know its x coordinate. But for its y coordinate, as this point lies on the straight line y equal to 11, then the y coordinate will be 11. Again, using the informations EH equal to GH, we're going to find the coordinate of H. So here the distance EH will be the square root of x minus 0 square plus 11 minus 7 square. As for the length GH, it will be square root x minus 7 square plus 11 minus s square. So next, I'm going to square both sides to cancel the square root. So what left on the left hand side, it will just be x squared plus 4 square. And on the right hand side, it will be x minus 7 square plus 3 square. So next, on the left hand side, we're going to get x squared plus 16 equal to, expand the x minus 7, we're going to get x squared minus 14x plus 49 plus 9. So here we can just cancel the x squared on both sides. As you move the x squared to the left hand side, it will be x squared minus x squared, and it will be equal to 0. So next, I'm going to move the negative 14x to the left hand side and this 16 to the right hand side. So we're going to get 14x equal to, so 49 plus 9, here we're going to get 58, then minus the 16. So 14x is equal to 42. Then x is equal to 42 divided by 14, which is equal to 3. Therefore, the coordinate H will be 3, 11. Number 2, find the ratio of the area of the triangle EFG to the area of quadrilateral EFGH. So first, we're going to find the area of triangle EFG using the shoelace formula. So here we are going to arrange the coordinate anti-clockwise. Start with the coordinate E. So it will be 1 over 2. Start with the 0, 7, followed by 4, 4, 7, 8, and end with the first coordinate. So next, 1 over 2, then we're going to multiply the sum of all products in this direction. So 0 times 4, we're going to get 0. 4 times 8, we're going to get positive 32. 7 times 7, this one is positive 49. Then we're going to minus the sum of all products in this direction. So bracket 7 times 4 is positive 28. 4 times 7, positive 28. 8 times 0, this will be 0. So this is equal to 1 over 2. So the answer in the first bracket is equal to 81. Then minus the 56, the answer in the second bracket. So this is equal to 1 over 2 times 25. So the answer for the area is 12.5 unit square. Next, we're going to find the area of EFGH. Again, I'm going to using the shoelace formula and arrange the coordinate anti-clockwise. Start with the coordinates E. So it will be 1 over 2. So start with the coordinate 0, 7, followed by 4, 4, 7, 8, 3, 11, and end with the first coordinate. So next, it will be 1 over 2 times the sum of all products in these directions. So bracket 0 times 4 is 0. 4 times 8 is positive 32. 7 times 11, this one will be positive 77. And 3 times 7, this will be positive 21. then minus the sum of all products in these directions. So bracket 7 times 4, positive 28, 4 times 7, positive 28, 8 times 3, this one is positive 24, 11 times 0, this will be 0. So this is equal to 1 over 2 times. The answer in the first bracket will be 130 minus the answer in the second bracket, which will be 80. So this is equal to 1 over 2 times 50. So the area will be 25 unit square. So the area EFG to the area EFGH, this will be 12.5 to 25. So we can simplify this by dividing both with 12.5. So the ratio will be 1 to 2. Questions number 9. Point O, P, Q, and R are the vertices of a quadrilateral such that M is greater than 0. A. If the area of OPQR is 34½ unit square, finds the value of M. So here we're going to find the area using the Euler's formula, and we are going to arrange the coordinate according to the point OPQR. So here 1 over 2. So start with the coordinate 0, 0, followed by M plus 1, M minus 7, then 2M plus 1, 2M, M plus 6, and end with the coordinate 0, 0. This will give us the area of 34.5. So next, I'm going to move the 1 over 2 to the right hand side. Next, we're going to sum of all products in these directions. So 0 times M minus 7, this will be 0. And M plus 1 times 2M, we're going to get plus 2M squared plus 2M. And when 2M plus 1 times M plus 6, expand this, you're going to get 2M squared plus 12M plus M plus 6. And the last one, M times 0, this will be just 0. Then we're going to minus the sum of all products in these directions. So 0 times M plus 1, this will be just 0. And expand, when M minus 7 times 2M plus 1, you're going to get plus 2M squared plus M minus 14M minus 7. And 2M times M, here we're going to get positive 2M squared. And M plus 6 times 0, this will be just 0. So this will be equal to 34.5 times 2, which is equal to 69. So here for the first bracket, 2M squared plus 2M squared, here we're going to get 4M squared. So 2M plus 12M, and plus M here, we're going to get positive 15M minus plus 6. And as for the second bracket, the 2M squared plus 2M squared, we're going to get 4M squared. So the plus M minus the 14M, we're going to get negative 13M, then minus 7. So this is equal to 69. So next, we're going to get everything out of the bracket. So this will be minus 4M squared plus 13M plus 7. So here when 4M squared minus 4M squared, this will be cancel. So 15M plus 13M, we're going to get 28M. And positive 6 plus 7, we're going to get positive 13. So this is equal to 69. So next, I'm going to remove the modular signs. So we have two possible answers. One is positive 69. The other one will be negative 69. So 28M plus 13 equal to 69. The other one will be 28M plus 13 equal to negative 69. So for the first one, 28M is equal to 69 minus 13. which is equal to 56. Then m is equal to 56 divided by 28, which is equal to 2. As for the second one, so 28m is equal to negative 69 minus 13, which is equal to negative 82. Then m is equal to negative 82 divided by 28, which is equal to negative 41 over 14. So here in the question is stated m is greater than 0. Therefore, the correct value for the m will be m equal to 2. Questions B, hence finds the area of the triangle OPR. So now we know that the m is equal to 2, then the coordinate P will be 2 plus 1, the other one will be 2 minus 7. Then the coordinate P will be 3, negative 5. As for coordinate R, it will be 2, 2 plus 6. Then the coordinate R will be 2, 8. So now we can find the area of the triangle OPR. So it will be 1 over 2. So we're going to start with the coordinate O, which is 0, 0, followed by P, 3, negative 5, and R, 2, 8, and end with the first coordinate. So this will be equal to 1 over 2 times the sum of all products in these directions. So 0 times negative 5, this will be 0. 3 times 8, positive 24. And 2 times 0, this will be 0 as well. Then minus the sum of all products in these directions. 0 times 3, 0. Negative 5 times 2, this will be negative 10. And 8 times 0, this will be 0. So this will equal to 1 over 2. So the first bracket, the answer is 24. Then minus the answer in the second bracket is negative 10. So this is equal to 1 over 2 times 24 plus 10, which is equal to 34. 1 over 2 times 34, the answer will be 17 units square. Questions number 10. The coordinates of 3 LRT stations, Payaredan, Kampong Raja, and Panjang Sari are represented by points A 09, B 70, and C 12, such that one unit represents 100 meter. Finds A, the distance in kilometer between Payaredan stations and Kampong Raja stations. So here we can find the distance using the Pythagoras theorem, as we know the length from point A to the origin here is 9 units, and from the point origin to the point B here is 7 units. And the distance between Payaredan and Kampong Raja will be the hypotenuse. So the distance will be 9 square plus 7 square. So this is equal to square root 130, which is equal to 11.402 units. So from the questions here is stated 1 unit represent 100 meters. So 11.402 unit will be 11.402 times 100 meter. This is equal to 1140.2 meters. But the questions want the distance in the unit kilometer. So to convert meter to kilometer, we're going to divide it with 1000. So here we're going to move the decimal places 3 times to the left hand side. So it is equal to 1.1402 kilometer. Questions B. Finds the actual area in kilometer square of the triangle formed by the 3 stations. So here we can find the area using the shoelace formula. So here we're going to arrange the coordinate anti-clockwise. Start with the coordinates A. So 0, 9 followed by 7, 0, 12, 12, and end with the coordinate A. So this is equal to 1 over 2. Then we're going to multiply with the sum of all products in these directions. So 0 times 0 here we're going to get 0. 7 times 12 is positive 84. 12 times 9, this one is positive 108. Then we're going to minus the sum of all products in these directions. So 9 times 7 is equal to 63. 0 times 12, this one will be 0. 12 times 0 will be 0. So this is equal to 1 over 2 times. The answer in the first bracket will be 192, then minus the answer in the second bracket, 63. So this is equal to 1 over 2 times 192 minus 63 is equal to 129. So 1 over 2 times 129, this is equal to 64.5 unit square. So here we want to find the actual area in kilometer square. So here we need to do the conversions. So here we know that 1 unit is equal to 100 meters. Then when we convert the 100 meter into kilometer, this will be equal to 0.1 kilometer. To get the value of 1 unit square, we're going to square both sides. So 1 unit square will equal to 0.01 kilometers square. So to convert 64.5 unit square into kilometer square, we're going to multiply the 64.5 unit square with 0.01 kilometer square. So this is equal to 0.645 kilometer square.